Okay, good afternoon, everybody. I want to welcome you to the latest in our series of Center for Transportation webinars. My name is Robert Puentes. I'm the president and CEO of the Center for Transportation. For those who don't know, ENO's mission is to shape public debate on critical multimodal transportation issues and to build a network of innovative transportation professionals. And I'm really excited for today's webinar on AI and transportation. I think we all know that artificial intelligence, or AI, is having and promises to have a huge impact on lots of different aspects of modern life, and transportation obviously is no exception. But it's moving fast. I was just at a conference where there were lots of presentations about this, lots of discussion about it. And I think while technology has always been a major driver of change in transportation, there is a need for transportation professionals today to understand what AI is, how it works, as well as its limitations and also its challenges, especially in making decisions on when and how it is being applied. So lots of discussion about AI, but not a whole lot of deep understanding throughout the transportation community. So to inform that conversation, ENO released a paper back in August of 2023, designed specifically to set the stage for that discussion. And I'm really happy that we have the author of that paper here with us today to present. Renee Autumn-Ray is the Senior Director of Transportation Policy at Hayden AI. Renee has worked with transportation technology and policy issues at many different levels of government for over 15 years. And she's going to discuss the findings and the content of that paper and how AI is affecting transportation today and into the future. And then following Renee, we will have Samir Sharma. Samir is a member of ENO's board of directors. And most recently, he was the global GM for new business initiatives for AI and 5G solutions at Intel. He is a global thought leader in many aspects of transportation technology, helps us understand these issues here at ENO, including AI. So Samir is going to provide his perspectives. We'll engage in some discussion between us, and we're going to take your questions and your comments. So please use the Q&A function on the webinar website to submit. You don't have to wait until people are done talking. You can submit those anytime, and we'll kind of take it conversationally as we go through the discussion. So just so you know, the paper is available on ENO's website, and the recording and the slides will be available on our YouTube channel. So I want to thank you all very much for taking the time to join us today. I'm really looking forward to the discussion. So with that, take it over, Renee.
Wonderful. Thank you so much. I think we can actually go ahead and move to slide 4. And I want to start by saying I'm so excited to have been able to partner with the ENO Center again. I've really learned a lot from the educational programs they've put on over the years. They're such a well-respected research center, and I'm very happy that I was able to work with Rob, with Samir, and with others to bring this paper to light. And frankly, I wrote this paper because I read news stories regularly about artificial intelligence. And, I've read books and I feel like I'm up to date on current events, but I did not feel that I was coming out of all of this reading with a really clear idea of, what AI is, the tools that kind of bring it together, how it's being developed, and what actually made sense for me as someone who works within the transportation industry, how it was going to be relevant to me. Obviously, my current day job, I work for a company that is providing AI to transit agencies, but as someone who's worked at several different levels of government, I think it should be very clear how technology is a useful solution for, folks who are responsible for serving the public and improving mobility for everyone. So that was what prompted me to write this paper. And I think that when you look at popular media, it's pretty clear that artificial intelligence is in fairly widespread use for a lot of consumer products. So for instance, if you shop on Amazon and you get product recommendations based on something you've put in your cart, if you're someone who has a Netflix subscription and Netflix recommends, a new TV show based on something you've watched, those are a couple of ways that artificial intelligence is being used in consumer products. But I think it's a little less clear where it's being brought to bear in transportation, with, of course, the exception of automated vehicle technology. And although I think AVs have taken up a lot of air in the room in terms of our understanding and the way that we think about AI in transportation, there's a lot of other potential applications across the industry and across modes. So those are the things that led me to write this paper. So we can actually move to slide 5. I wanted to first ground us in a visual that helps explain some of the most popular concepts and also makes it clear that, artificial intelligence in the past several years has been increasingly exponentially improving in terms of how it's being applied, the quality of insights that we're able to gather from data that is having artificial intelligence applied to it, but it's still based on a foundation of concepts that have been in use for decades. So you can see here this gray box of computer science, a field of study that has been around for multiple decades. Artificial intelligence fits within the computer science framework, but incorporates a lot of additional methods within it. So, for instance, most people are going to be familiar with machine learning here on the left in the orange bucket. There's also something on the far right called computer vision. So, for instance, machine learning is a very broad and very complex system of tools that can be applied to many different kinds of data sets. Whereas computer vision, we're going to be thinking of AI that's being applied to images, right? Because you've got the word vision there as a kind of clue. We've also got deep learning, which spans both machine learning and computer vision, and is where a lot of the innovation within artificial intelligence has been occurring in the past several years, and even additional concepts like a convolutional neural network. So you can see that when we talk about artificial intelligence, sometimes it's helpful to dive a little deeper and say, what's the actual tool that you're going to be using, beyond just putting the label artificial intelligence on a specific technology solution. I think explaining it in a little more depth is really helpful for folks who may be less familiar to understand, what these concepts actually mean. I think it also helps visualize, how a particular kind of AI technology is going to help someone who works in the transportation sector, solve a problem they're having, do their job better. So we're going to switch actually to slide number 6. Um, this slide is way too big for anybody to try to read, but what I wanted to walk you through is within this white paper that I published with the Eno Center, not only do I sort of define the concepts and visualize them and try to ground them in that perspective, I also give a few examples, specific examples of how specific artificial intelligent concepts might be used across different modes. So for instance, airlines, within transit, within just highways, traffic signals, that kind of thing. Um, One thing you may also notice when you're looking here on the left, one thing that I found really helpful when I was trying to wrap my arms around the breadth of techniques and tools that artificial intelligence can encompass is to think about the data that you're using to solve a problem. So the data can be, numbers, can the zeros and ones in code, or numbers of things like, vehicle miles traveled or trips in a year. It can also be words. So obviously, if you think about a large language model like ChatGPT, most typically it's applied to, I mean, it's a language model. So you're thinking of, what's a situation where perhaps I have a large number of documents and I want to extract useful information from a portion of them. That might be where you use an AI tool focused on language. And then finally, I mentioned computer vision in the previous slide. So you can also think about, maybe I have a large set of images and I want to figure out, can I use AI to streamline and simplify the work that I need to do to make these images be useful to me in a more time efficient manner. So these two, the figure on the previous slide and this table, are just literally copied and pasted from the paper, and they're an example of the kind of information that I included in the policy brief to really be a reference guide for folks at agencies or in consulting firms who are trying to get a better grasp of what artificial intelligence is and how they might apply it in their work. So that's actually the end of the slide deck. So we can move to just showing Samir, Rob, and myself. But what I wanted to wrap up with is that, I've worked in a number of different technology pilots over the, 15 or so years that I've worked at local and regional government and as a federal contractor. And I think whatever the technology tool that's being introduced is, as practitioners, we're still left with, the most important question is, what's the problem that I'm trying to solve? Is technology actually something that can help me solve that problem? And only in that case, should I be thinking a little further about, looking at a specific tool to figure out how it's going to help me get my job done. And I can also say that one thing that's really important as practitioners and policymakers are thinking about the significant impact that artificial intelligence is likely to have on our careers is it's very important that we still understand that people are accountable for the work that gets done. And when you're thinking about artificial intelligence, it should be a tool, but the decision should still rest with the practitioner or the policymaker who's implementing the tool. And I think that is a really helpful way to think about how we can responsibly and ethically adopt AI technologies and use them to improve the work that we're doing within the transportation industry. So thank you very much. And, I'm thrilled to be here and to discuss some of these questions with you.
Thanks very much, Renee, and thanks for leaving us with the last set of comments. I think that makes a lot of sense. Samir, let me turn it over to you for reactions and your perspective on all this.
Thank you, Rob. My first reaction is going to be hard to follow up how succinctly Renee described everything with anything more useful, but I'll try my best. Look, I want to start by thanking Eno and specifically Rob and team for creating a platform where we can have this conversation. If you look at the composition of this panel, if you look at the profile of our audience, this is exactly what needs to happen, because when we talk about AI and transportation, we are talking about two worlds, two set of people who may both speak English or another language, but they are speaking different words. The world of AI lives in, creating models, model architectures, annotation, labeling, testing, validation, all that stuff. The world of transportation lives primarily in cement and steel and how to build physical infrastructure and move physical stuff and people, right? Let's face it. So I think it's very imperative that we come together, and 45 minutes is nowhere near enough to do justice. So today is the start of a conversation, and what we are hoping to do by putting this paper out, by having these webinars, is engage and put forth a point of view, but also hear from you and get feedback on what's important to you, what are you struggling with, and so on. So let me just build up on what Renee described, right? If I zoom out, and I've been in the technology industry now for 23 plus years, and I reflected all the transitions that have happened, the advent of internet, the availability of cloud computing, the mobile revolution, and the apps ecosystem and the creativity that it unleashed, there are a couple of common themes. In almost all these transitions, it took longer for the transition to happen than we thought it would at the start. Because the start of a transition typically results in a bit of a hype, excitement, and I think we see some of that happening with AI right now. So that's the first thing to keep in mind, that the transition will be longer in terms of time. The second thing we always see is, or we have seen at least in these last few transitions, is that the impact has been far larger and broader than we thought. We could not imagine the possibilities because those possibilities did not exist. And while humans are creative, there's a limit to our imagination. So some of those possibilities unfolded as we went through the process of the transition itself. And the third thing is, in all these transitions, there was typically an inflection point, and that inflection point had an economic angle. And I'll explain a bit more about what I mean here. Renee talked about the autonomous vehicles and the advent of it. And frankly, I think we've gone past the hype cycle into a little bit of pessimism about how long will it take for level 5 automated cars to move around. The reality is, with respect to that use case, we have not hit the inflection point, or at least the economic aspect of that inflection point. When your robo-taxi is going to cost $500,000, we cannot expect anybody who is used to buying cars between $20,000 and $80,000 to buy them and use them, because we're going to use them for an hour or 2 or 3 a day. Whereas a robo-taxi can be utilized 24 hours, and therefore it can make economic sense to deploy it. So I think the inflection point is a function of 3 things: the technology at the right point in time. So in this case, compute, connectivity, processing at the edge. the economic incentives aligned, affordability, scalability, and so on, and the policy and regulatory framework being ready to accept these transitions. I hear a lot of fear and anxiety about what artificial intelligence will do, how it will replace humans, and so on and so forth. And frankly, I think as a community, we've done ourselves a big disservice by calling it artificial intelligence. We should have really called it AI, as in augmented intelligence, because for the foreseeable future, that's exactly what it's going to do. It's going to be your co-pilot. It's going to be the thing sitting beside you that's going to help you do your job more effectively and in a better way. So for everybody who's sort of fearing AI, my recommendation is let's take a deep breath. Let's look at how resilient we have been in terms of absorbing these big transitions that have come in, and giving us as a global community some credit for how far we've come, but also prepare ourselves for how far we can go with whatever is going to be available to us in the next decade or two. The previous generations used to deal with one big transition in their lifetime. Advent of steam engine, availability of electricity, the industrial revolution. We've already dealt with 3 to 4, and we've done remarkably well. So that should give us confidence. Now, what does that mean? So that's more of a backward-looking view, looking at what can be learned from the past. And so as we look forward, what does it mean for us? I think if you are a transportation practitioner, please do understand you need to move from thinking about transportation as cement and steel to thinking about transportation as also including bytes and transistors. So silicon, software, AI, connectivity, these have to be part of your thinking from day zero, not even day one. And if you don't do that, then you are risking building the infrastructure of tomorrow using the thinking of last century, which obviously is very counterintuitive and counterproductive, especially when we are investing trillions of dollars of taxpayer money, not just here in the US with the Infrastructure and Jobs Act, but in Europe, in India, in parts of Southeast Asia, and now also in Latin America. So think about this sort of the bytes and transistors as your co-pilot, making the overall infrastructure not just effective, but intelligent. And what I mean by intelligent is it gets better over time. I distinguish, when it comes to implementing things like AI and connectivity, I distinguish between smart and intelligent. To me, smart infrastructure is something that, you tell it needs to do something and it does it well. Intelligent infrastructure is infrastructure that gets better over time. As a traffic camera is able to process information about the traffic flow throughout a day or days of a week or even months of a year, it's able to gather that intelligence and tune the red light and the green light timings dynamically to say, hey, this part of the intersection flow tends to be backlogged a bit more. So let me just give it a bit more, open the aperture a bit more in terms of letting vehicles through. So those are examples. That's the way I think we need to approach this. And of course, I want to make sure we leave enough time for questions as we go through, the rest of the webinar today. Back to you, Rob.
Fantastic. Thank you very much, Samir, and thank you, Renee. It was really, really grateful for your time and for your comments. And we have some questions that are coming in now. So again, please use the Q&A function on the website to submit questions and comments, and we'll take those as we go through for the next few minutes. But I want to start with something, Samir, something you just said. It's some comments that were coming in. Just some folks who are wondering, I think maybe just kind of as a foundational question. As we said at the beginning, transportation and technology have always been together. There's been a lot of these leaps over time. I spent my career for time at the Intelligent Transportation Society of America. We talked about technology and infrastructure and all those things. Is there anything more to say about the difference then between kind of just the technological evolution in transportation and what's happening now with AI? You mentioned smart versus intelligent and those anecdotes, but for both of you, how do you contextualize the technological change that comes with AI today versus technological improvements in the past?
Rob, I'm actually going to use this question as a bit of a jumping off point because we can talk frameworks and ideas all day long. I want to share some examples of what's happening today that could not be done in the past. So let me pick 3 to 5 examples just to walk through and give you all a breadth of both how different countries in the world are thinking about it, but how also different kind of companies, scrappy startups, big system integrators, physical infrastructure implementers are thinking about it. So let's sort of fly over and take an example out of India. One of the religious events in India that happens once every 6 years attracts about 250 million people. And historically, it's been a nightmare where, so I've never been there. I've just heard that it's been a nightmare logistically, just in terms of moving people, crowd control, safety, all those things. The last one that was done had 1,100 cameras. It was implemented by a large system integrator called Larsen and Toubro L&T out of India, that itself has a storied history. And they had 1,100 cameras and 19 traffic junctions fully instrumented. So these cameras using AI were trained to detect overcrowding. So the moment any square meter had more than 3 people, the cameras would create a heat map and hotspot. And then you could have human intervention to minimize people going into that area and letting the backlog clear itself. Simple idea, right? But what it resulted in, instead of crowd and stampede and people pushing each other, people had a good and frankly a spiritual experience that they were looking for versus trying to get to wherever they need to get to. So the flow of traffic, everything went much more smoothly, and a day and night difference, right? So that's one example. The second example is a large system integrator out of Europe with a subsidiary in the US called Ferrovia. If you've been to London, they operate the Heathrow London Express, and they're going through a transition of applying digital technology to physical infrastructure. Here in the US, closer to the home, they have instrumented I-66 corridor in Texas to be fully instrumented on a few miles with 5G connected smart nodes. And what that does is, it gives you better traffic flow, better first response. If there is an accident, it gives you better connectivity, both for the car and for the person who's sort of driving along the highway. But in the future, it's really instrumented to allow the coexistence and commingling of conventional vehicles, semi-autonomous and autonomous vehicles, because all of them will have different requirements from the surrounding infrastructure. That's a second example. The third example I can share is Intelligent Security System, right? A small, scrappy startup. They have come up with a new idea called Soffit. And what Soffit is when a pedestrian starts crossing the road in the dark, the camera will detect it, analyze it, and use a spotlight on the pedestrian. So they are much better visible as they're crossing the street. Why is it important? We know 50% of the accidents, fatalities, injuries happen at traffic intersection. So if you can improve the safety of the traffic intersection, you have a multiplier effect on the overall safety of our transportation system. When I was at Intel, we did work with the city of Chicago to dynamically analyze capacity utilization post-COVID because of social distancing and reallocate public transit vehicles, buses from less busy routes to more busy routes. Real time, right? Not after the fact, but real time. These are all things that would not have been possible if we didn't have these capabilities of AI, but equally importantly, connectivity coming together. So hopefully that gives people a flavor of why it's different this time around.
Yeah, I think so. I think it will. Just judging from the comments, and this is the kind of thing that I think people are looking for, is specific. Conceptually is one thing, but how it all is applied. And so it was very helpful. So Renee, let me ask one for you. So we're based here in Washington, but we do work with policymakers all across the country at lots of different levels of government. What do you say to people who are concerned about using AI in government specifically? Government tends to be cautious, obviously, for lots of different reasons about this stuff. So what do you say to people who are concerned about using AI in government?
I think it's a pretty reasonable concern. There's been a lot of, articles written and, public opinion that people, if you're not sure of what something is, I think you're naturally a little more skeptical about how it's going to be used. And, we're in an interesting challenge where the US does not have a comprehensive AI regulation. I know the EU has been working on it, but it's also an industry that is advancing so rapidly that, any regulation you put in place would be hard to stay relevant and fresh. But, we have existing decades of case law around how government is able to collect data. Where are they able to collect it? How do they store it safely? What are the rights and responsibilities that government agencies have to residents and citizens in their jurisdiction? And so we already have a lot of regulation that helps public agencies understand how to operate. And frankly, I think there is plenty of existing, policy guidance and regulations that have been adopted at various levels of government that can be a helpful guide to public agencies as they think about how to adopt AI. And I think to my previous point, understanding that a person should be accountable for a decision is also really important to allay public fears about how AI is being used.
So, building off your comment, what level of government should be responsible for this mostly? We a lot of discussion here in Washington on the federal level, but as you mentioned, it has applications all throughout. So, how do you think about the different levels of government who should be leading on AI regulation?
Um, I I personally like a more federal approach because I think it's easier to level the playing field. We've got 50 states, thousands of counties and cities. And I think to have a more central body take the lead on regulating a new technology, I think is more appropriate. In some ways, I think it's been challenging that some regulation of autonomous vehicles has been a little more piecemeal at the state level. And so, that can be helpful in some ways because you can pilot different solutions in different markets. But I think it also creates a challenge to think about, if something, if we have a technology that works and is useful, how useful is it if it's only legal in one or two states?
Rob, if I
And
can,
I think,
I think
please.
yeah, I was going to say, Renee, I think hit the nail on the head, right? And I'm going to complement her answer by talking about what I think the technology industry needs to do it. I think we need to demystify AI a bit more. When we talk about deregulating AI, what does it mean? It's a blanket statement, and it's a, you need to sort of think about an AI implementation as it's a piece of silicon with some software and math running on it in a system, and then it's deployed on an actual use case that you and I can experience, hopefully in a more efficient, safer, better manner. We don't need regulation of the silicon and the software and the math because they are on a trajectory where people are doing their job, the human creativity is being unleashed, and all those, progress, all that progress is going to benefit both AI and non-AI use cases. I think the first point of intersection where policymaker need to come in is data. So start thinking about what data is being collected. Is it representative enough of our population? How is it being protected? How is it being utilized? How is it being audited? When issues are found, how is it being fixed? I think these are all the things where I think the government intervention, I shouldn't say intervention, government clarity would really, really help. And then we come to the next stage, which is the actual deployment. I think that's where government stepping in and saying, here are some established standards would play a key role. And let me give you an example, right? Today, when you're driving on the road, all of us know exactly what a double yellow line means or a broken white line means. Right? We all have sort of accepted that the optimum safe speed is somewhere between 55 and 75. We need the equivalent of these lane markers and safe speed zones on the AI side. What does that look like? Can it be done without government involvement and standardization? Sure, right? The question is not a right or wrong answer. The question is which is the more optimum path. And if we leave this to the market, if we leave this to this fragmented ecosystem, to use a transportation analogy, I think we'll still get there, but the road will be winding and long, right? And will be accident prone along the way. So I would rather have that clarity and then get to the answer a bit more quickly. And I think that's where I think the government involvement matters a lot. Policy intervention, it matters a lot. And the final thing I would say is it's not just standards. I think it's also interoperability. No one company or even a small group of companies can do it all. So I think it requires some level of, hey, how do these things interface with each other? In other words, we can all build different houses, but we better standardize on what our doors and windows look like, because that is really what enables us to go in and out and the fresh air and light to come in. Right? Renee, I think you were trying to say something.
Yeah, I want to piggyback on one of the points that Samir made about the fact that probably every data set is going to be flawed in some way. For instance, in terms of, population level data around, age, race, ethnicity, there's a lot of concern around, how data are being used and if they're representative of specific populations. In the same way that I think some folks are naturally skeptical of technology that is new, I think other people sort of imagine, oh, it's technology, everything is fine, I don't really have to worry about it. And I think continuing to have pretty serious discussions and understanding methodology for how data is collected, gaps in coverage or quality of data, and how that may skew results in a way that raises some concerns over how data is being used to make a decision is going to remain really important for the foreseeable future, if not forever.
Yeah, I agree, and I think there's some concern and some folks we've heard today. I mean, obviously, data standardization matters, but at its heart, I mean, AI relies on all this data, and it's the whole notion of garbage in, garbage out, right? If the data going in isn't any good, the AI applications aren't going to be very good either. So those are great points. I'm going to read this question here. It's really well stated here. Can you provide some guidance on the initial steps and recommended learning pathways for individuals who are aiming to acquire a comprehensive understanding and proficiency in AI as it pertains to transportation? As we mentioned at the beginning, there's doing a lot of this, and Renee wrote the paper in order to provide that fundamental understanding for people. But what are those learning pathways as far as you can see them for people who want to get smart about it?
So go ahead, Renee.
Oh, I was going to say, I'm actually going to find a way to put this in the chat, but one of the sources that was most helpful to me as I was writing the paper is an online course called Elements of AI. I think it's out of the University of Helsinki. That was an extremely helpful sort of plain language educational course that helped me build my skills.
I was going to build up on Renee's question, Renee's response to say, I think first of all, make a decision on how do you want to learn AI, because AI could be learning the tools and developing new tools to optimize AI. AI could be understanding what the different architectural frameworks and models look like and how they're evolving. It could simply be, hey, I want to get better at prompts for generative AI. We didn't talk about generative AI. Generative, the word comes from the fact that the capabilities of AI have reached a point where it can generate text, images, content for us, right? So, how do you deal with it? I think that's a whole skill set in itself. So first of all, make that decision, right? What is it that you want to learn? Because learning everything is going to be hard, not only because there's a big body of knowledge, but that body of knowledge is evolving so quickly. It's hard even for people like me who are doing this every day to keep up. So once you've done that, I think be careful. I think there's a lot of people pitching paid courses because this is such a hot topic. And I feel like there's a lot of resources being put on the web by universities, by companies that you can easily use as the first step, right? To say, hey, is this something that interests me? Is this something that's useful to me? And how do I use it? And then you can make the decision to go pay for education or whatever that you need to do. And I'm pointing this out because we need AI cannot be something that we put in a silo and a few people work on it and the rest of the society benefits from it. I think we have to get used to, as I said, having our co-pilot, AI as our co-pilot, and that will mean evolving all of our skills. And I give myself the same advice that I give my high school teenager on how to learn AI, that we are all starting from scratch in many ways, and we always have to assume that there's a lot we don't know. So start with a position of humility and be willing to learn new things and experiment with it, right? And be prepared, mentally prepared that as you learn stuff, it's going to become very quickly obsolete, right? And we didn't talk about skill set development. I think that's going to be a massive focus area for us as a society to absorb this pace of change coming our way.
I'll follow up and
Renee,
say, in addition to that course, I signed up for probably half a dozen different AI related email newsletters, and I'll skim through them once or twice a week. And if they're sharing a tool that I feel like is relevant to my job, I'll just play with it for 10 or 15 minutes and see if I feel like it's helpful. And frankly, I think just practicing with something has also been a really good learning tool. And I just think of it as part of my personal professional development at this point.
And it's fun. Your comment, Samir, about you're learning something that's going to be quickly become obsolete. It's tough for I think tough for folks to start to dig into it for that reason. Someone asked, "Is there an AI for Dummies book?" And I don't know if there's a book, but again, I would direct you to the paper that Renee wrote. It's on the Eno Center for Transportation website. Chris, maybe you could put that in the link in the chat for us. But it's again designed to be a fundamentally foundational piece in order to introduce folks to the topic. So I would encourage you to take a look at that.
Absolutely.
And Rob, we can provide
Yeah.
more resources. I think it's a good ask. I think this is part of our role to educate the community, and so we'll sort of combine a few set of resources. And again, as I said, they'll hopefully will be fresh for maybe about 6 months, and they'll become obsolete. So
Yes. Yeah.
Unfortunately, true. And I think it matters because we mentioned, I think you both mentioned kind of the assuaging some of the fears and addressing some of the legitimate concerns that people have. We talked about privacy and data. Cybersecurity comes up a lot, and it's come up here with the questions. How what is the relationship then between cybersecurity concerns and AI? Does it make it more difficult? Does it make it easier? How do you think about that nexus between those two topics?
So I think of AI as a tool, right? It's a tool that's available to the good actors. It's a tool available to the bad actors as well. So when we democratize AI, we are making it available to everyone, right? The question is, how fast can we move to stay one step ahead of the bad actors, right? Let's talk about cybersecurity for physical infrastructure before and after AI, right? Before the advent of AI, I think cybersecurity was always a concern. But if you look at historically transportation systems, they tended to be closed embedded systems, right? You program them, you leave them alone. Somebody had to physically go there, pass some physical security usually, right, to mess around with them. I think we opened the first possibility for a cyber attack the moment we decided that we want this infrastructure to be upgradable. We wanted to fix things, we want to improve things over time, and therefore we need to connect it. And the moment you connect something that has got compute capability, that compute capability can be harnessed for an attack. And that's exactly what cyber attackers were doing. The surface area for this attack increased massively because I think we trained both the enterprise and the consumer while using their phones and laptops to be mindful of things like, hey, make sure you're running an antivirus software or an anti-malware software, and don't, succumb to social engineering or phishing attacks and so on and so forth. How do you imbibe that smartness, that intelligence in the physical infrastructure? That's where AI comes in. So the tools are going to get more sophisticated, but so will our capabilities to instrument the infrastructure to be more resilient. And I'm not saying if, when that attack happens, because it's bound to happen, how do you recover quickly? That resilience, that self-healing, I think will also come from AI. So as an example, if there's a traffic intersection and somebody decides to mess with it and turn everything red or green or whatever, just to create, confusion and chaos, is there a backup system that says, look, we are detecting something weird happening. We're going to shut down the connectivity to the cloud, and we're going to default to a very conservative, even if it's non-efficient, but conservative behavior. So we go back to fixed red light, green light timings. That may cause traffic to back up, but at least it won't create the kind of chaos that can be created by turning all the lights green all the time. You can imagine, the number of accidents that can happen. So I think that's how we have to think about AI. It's a tool available to us for resilient, for recovery, but it's also a tool available to the bad actors who are going to use it to increase the surface attack area.
I'll add a couple of points just using the specific example of some of the things that we do at Hayden AI, which I work for. So obviously there are specific certifications that the federal government offers around, cybersecurity and data protection, but also, we approach security as a practice. So it's not a certification process. It's an ongoing practice in which we have, routine, third parties that attempt to break into our system to ensure that if they identify any weaknesses, we're able to mitigate those and prevent them from happening again. Samir mentioned earlier edge processing, and so that's a situation where you only use the information that's relevant. So for instance, the company I work for does traffic enforcement from equipment that's on board a vehicle. Instead of having 16 or 18 hours of video from the full day of a bus traveling, edge processing minimizes so that only the traffic evidence package that's relevant to the agency gets transmitted through the cloud. 95 or more % of all that video gets destroyed on the vehicle. It never gets shared. And I think a final thing is you also think about, not just equipment and data, but also people. So, a large majority of cyber attacks still come in through, people that click on links in phishing emails. And so, in addition to ongoing training of employees, it's also thinking about how do I limit the access of more secure parts of a system to only the employees that should have access and need to be able to work on those data that may be sensitive.
And again, probably roles for regulatory kind of addressing some of those concerns as well. A couple of questions here about transportation planning and AI specifically. So maybe Renee, maybe one for you. I've heard about colleagues taking initial steps to use generative AI to develop transportation planning and policy documents. What guidance would you offer around this particular use case?
I think using AI for planning documents and policies is probably going to be a pretty challenging lift for that particular problem, just because there are so many idiosyncrasies. I mean, every city thinks they're special, but in a lot of ways it's true because, cities are all different in terms of, the age of the infrastructure, the nature of land development, and the presence of, public rights of way, demographics and transportation needs in specific populations that can vary from neighborhood to a region itself. Um, I could, frankly, where I see a benefit in the transportation plan practice is being able to streamline and reduce the time and the human resources for something like a NEPA review, where you've got, extremely important but also complex documentation that needs to be done to ensure that a capital project, fits within environmental parameters. And I think that's a process where, you know, it can be extremely time consuming and extremely labor intensive. And I think that AI could be extremely useful in solving that particular problem more so than developing a new policy document from scratch.
I think you're right about the idiosyncrasies and specifics. I tried to use AI to generate some of my initial comments, and it wasn't quite right. So maybe it's something I was doing wrong, but couldn't get it customized exactly what I wanted.
Yeah.
Um, just a few more minutes. Just I want to finish with a kind of an aspirational question. So, of all of this we talked about, again, a lot of concerns and dealing with some of the challenges. What are you most excited about when it comes to AI in transportation? What do you think is what should people know about that really piques your interest? We'll have each of you answer that if you don't mind.
I can start. I think of transportation as the sort of the blood supply of this organism that we call the human society. I mean, you cannot do a job that you cannot get to. You cannot buy or sell something that cannot be delivered. And so I think, to me, transportation is the on ramp to economic opportunity. It's not just transportation as a vertical; it's the implication on the society. And when I look at the possibilities in terms of efficiency, safety, security, not just on traffic intersection and roadways, but our airports, our ports, and how our supply chain can be optimized, about the next generation of railway infrastructure in the US, but in many parts of the world, I think the possibilities are endless. And I think the big struggle is going to be, where do we go and fish in this massive ocean? Where are the most immediate and biggest areas of impact? And I think that's going to be a bit of a debate. I'm also excited about the 1.1 or 1.2 trillion dollars. These large numbers sometimes lose meaning, of investment that we're making in this country to refresh it from what was built in the 1950s to, hopefully, that represents something that's ready for the 2100s, right? Not just the 20th, 21st century. So to me, that's the big picture, exciting stuff. And I think having AI and connectivity at our disposal, and having forums like transportation to accelerate that conversation and convergence of how we think, I think, to me, that's super exciting.
I'd say for me, we're in some pretty significant challenges within the transportation industry, partly in terms of the fact that we've had rising rates of deaths on the roadways in recent years. And also, some of you may have seen, a recent New York Times article about the high cost of car ownership for the average American family. And the reality in the US is that based on our land use patterns and the way that we have historically funded and built transportation infrastructure, a car is usually the most reasonable option for the average family. So I would love to see us take advantage of some of these AI tools and figure out how do we both change our infrastructure in a way that's more supportive of multimodal options, allow Americans to reduce their dependence on cars and make living in the country a little more equitable for folks that are, on the bottom half of the income ladder, and also think about, are there some nudges or behavior changes that we can use to entice people to use those options? And frankly, as practitioners, think more about what people want, which is not something that we've historically spent a lot of time on in the transportation industry. And if there are AI tools that can help us do that by things like, surfacing, social media comments and putting them in a relevant format, those are all things that I think would really help us get to the transformational change that I think we need to make.
That's great. That's a great final comment. And I'm glad you mentioned that. We as Samir mentioned at the beginning, 45 minutes is not enough time to do this topic justice. And there are a lot of important topics we didn't get to, safety being one of them, equity, AVs, a lot of questions about AVs, climate, aviation, right? So a lot of things that we haven't got to yet. But I hope we can have you both back in the future to help us think through those particular topics, because I think this is exactly the kind of conversation that we want to have. And I think for folks who are listening, your comments about making sure that we're getting the system that we want, and AI's role in that, and trying to figure out what problem we're trying to solve, as opposed to technology for technology's sake. So lots of great examples. If you would like more information about Eno, you can check out our website at www.enotrans.org. When you're there, you should check out Eno Transportation Weekly. It's our flagship publication and an indispensable resource on all aspects of transportation policy and practice. You should also check out the range of professional development programs we have planned for 2024, including our long-running Transportation Senior Executive and Transportation Mid-Manager programs. As I mentioned, the recording from this website, from this webinar, will be up on our YouTube site. You can search for Eno Center for Transportation. And once again, my deep thanks to Renee and Samir and all of you for joining us today. Great questions, and this is just the beginning of the conversation. Thank you all very much. Be well, everybody.
Thank you.
Thank you.